Hey guys, picking up where I left off. If it gets kind of loud, I'm sorry. It's raining outside. So we've got our function sketched. We figured out that we were being bounded by the function itself, the x-axis and the y-axis. We were rotating it around the x-axis right here. That's what you see. And so it's going to give us this three-dimensional shape now, which is a sphere, okay, a semicircle to be exact. It's half of the circle. So now we have to find the volume of that sphere. So that means we need to do the integral, well, we need pi times the integral of our lower limit to our upper limit. Now remember, this is rotating about the x-axis, so these need to be in terms of x. So that means the smallest x we're going from is 0, and the biggest x we're going to is 2. So this is going to be from 0 to 2. Then our functions here have to be in terms of x. And remember from what we said before right here, we need to have a top function minus a bottom function squared, then dx. So our top function here, so the top function that we have that's being rotated, so in other words, the outside function of our three-dimensional object, which is that part of the circle, is going to be our function, which is 4 minus x squared. Okay, then we are going to subtract the bottom function, or I guess we could say the inside function, which here is just going to be the equation that equals the x-axis. So that is going to be where y equals 0. So this is minus 0, and all of this is going to be squared with respect to dx, because remember we said in that first video that this is representing the width of each one of our rectangles that we're finding. Okay, this gives us the height of each one of these rectangles, and then we multiply by pi because we're squaring it. That gives us the area, pi r squared, and then the height, okay, or the width. All right, so what's really nice about this is we can put this right into our calculator. For those of you that are using Desmos, okay, I'm going to try to show you what it looks like on Desmos. Let's see. Not sure where my screen went. Okay, let's see what I can do here. Okay. Bear with me. You're going to see an infinite screen here in just a second. Okay, so I'm just doing this to try to show you guys what, well, it might be easier if I do it on this screen over here. Yes, I have two screens. I know. My husband's IT. Okay, so when we type this in, I know some people are struggling with using Desmos, so I want to take a second and show you what it looks like. So all you would do is we would type pi, and you'll notice that it's going to give us pi. Then if you type int, it's going to generate an integral for you. Int, integral. Okay, then we're going to put our lower limit, which is 0, our upper limit, which is 2. Then we're going to put our whole function in just like we had it on our paper. So I'm going to put a bracket, then I'm going to put my little parenthesis, oops. Then I have 4 minus x. To make a square, you can use on your keyboard on number 6, there's that little caret, so shift 6, and you'll see that it's going to take you to an exponent. So we can square that, then arrow to the right and do your parenthesis to close that. Then we're just going to subtract our second function, which is 0. If you want to put that in parentheses, you can. Not necessary because it's just 0. And then we have to square that whole thing. So remember, that's the top function minus the bottom function, and now we're going to square it. So shift 6 to get the exponent, square, and then at the end you have to put dx. Okay. Are these giving us element list? What does that mean? Okay, well, let's see. Maybe I have to put parentheses around here? No? Not sure what that means. So I figured it out. It does not like the brackets, so it wants you to have a parenthesis here in the front and then a parenthesis here. So don't do brackets, just do an extra set of the parentheses before you do that square. And we're going to see that we're going to get 53.616, so 53.62. Okay, I'm going to go back down to my paper. Pardon me as I adjust. You get to see what I do all the time when I'm trying to get these videos ready, except I don't normally jump back and forth. Okay, so I'm going to go ahead and I'm going to put that number in here. We said that when we typed it in, we got a 53.62. Okay, so at least you guys got a chance to see what that looks like on Desmos. Okay, so let's look at example number 2. So example number 2 says find the volume of the solid formed by revolving the region bounded by the graph f of x equals the square root of x and the axes, the x-axis from 0 to pi. So you'll notice here this is giving us our interval. So that's going to be our lower limit and our upper limit because it's the x values. So it's going to end up being our a, that's going to end up being our b. We're revolving around the x-axis, which means we're going to be doing this horizontal rotation like we were talking about doing. Okay, so if we sketch a picture of this graph, okay, and you can do this on your calculator, you can do this on Desmos.com, either way. So we are going to go from 0 to pi. Okay, when we go from 0 to pi, we are going to get this function right here. So it's going to go like this. Okay, because remember this is a sine function, so this right here is pi, and because then it just keeps going like this, you know, our sine curve. This height over here is a 1. Okay, so this is our function, and it says that it's being bound by that function and the x-axis. So I've got this function and this axis right here that's bounding it. So that means we're looking at this area and we're going to revolve it around the x-axis. So if I rotate this around the x-axis, I'm going to get this piece down here, and it's going to become a three-dimensional object. Okay, this is going to be a -1. Okay, pardon me, those should really be together. Okay, so basically it's going to look like a football. Okay, it's going to be the shape of a football. Okay, and it's going to be completely solid and filled in. No holes, no nothing. It's just a solid football shape. Okay, so now we need to find the volume of it. So when we're talking about our function, we've got a top function, which is the outside of this object. So that's this piece that's being rotated. And then our inside function, or our bottom function that we're going to subtract, actually is just the x-axis piece right here. Okay, so that means we're going to have pi times the integral. Remember we said our lower bound is 0 on the x and our upper bound is pi. Remember those have to be in terms of x because we're taking this with respect to x because we're rotating it about the x-axis horizontally. Then we've got our function, so I'll put it in with parentheses so everybody sees how to type it on Desmos if you're using Desmos. Okay, this is going to give us our top function. Here our top function is the square root of sine x. Our bottom function is 0. We're going to square it and take it with respect to x. So notice all of this inside here, if there's a variable, the variable is x because we're taking it with respect to x, and these also have to be the x lower limit and upper limit. Okay, when we type this into the calculator, we are going to get 2 pi. If you want to leave it in terms of 2 pi, you can, or we can put it as 6.28. Okay, 6.283. If you want 3 decimals, that's fine. Okay, then we're going to look at the third example. So the third example is a little bit different because there's always something new and tricky. Okay, so on the third example it says find the volume of the solid formed by revolving the region bounded by f of x equals 2 minus x squared. So that's going to be a quadratic opening down. G of x equals 1 about the line y equals 1. Now, let's draw this and make sure we understand what we're looking at. So we've got this, okay? This function right here, 2 minus x squared, okay? That means it's going to go through here at 2, okay? And then it's going to, let's, negative 1, negative 2, negative 1, negative 2. So it's going to go like this, okay? And you would get these points by graphing on your calculator. So that's this function. Then I've got g of x equals 1. So g of x is just a second function, and it always needs to be 1. So that means we're actually looking, I'll use my pink, we're going to be looking at this line. So this is g of x equals 1. So we're really looking at this section, and we're rotating it about the line y equals 1. Well, y equals 1 is this pink line. So we're not rotating about the x-axis, but we're still rotating it horizontally, and it's rotating it on that piece that's completely touching that function right there. Okay, so it's completely touching that function, so that's good. So we still have a top function, that's this piece, and a bottom function, which is this pink line, and we're rotating it about the pink line. So we're still good, we're still following the same rules. So pi equals, so I need to know my lower and upper limit. So this is a negative 1, this is a positive 1. So negative 1 to positive 1, because these are x's, we're rotating horizontally. Okay, and then we've got our function. So our top function, which is 2 minus x squared, minus our bottom function. So before on the other two problems it was always 0. It's not a 0 anymore here because our bottom function is y equals 1. So 1 squared with respect to x. Okay, so then we're just going to punch this into our calculator. If you want to leave it in terms of pi, it'd be 1.067 pi. If you want to give me the whole decimal, great as well. Just make sure you can go back and forth between both. 3.35. Okay, now there are 4 examples on the practice page. I'm not going to work them for you, but I will put my answer key out there. Try to work them first without looking at my key. Okay, so this is what it looks like. Okay, these are the 4 problems that it's going to have you do. Okay, so go ahead and try all 4 of these first, then go look at my key. If you need help, I am going to be on It's Learning. On It's Learning. Not exactly sure what time, but if you need my help, let me know, and I will jump on almost any time. I'm thinking I'm probably going to start doing afternoons. I think that's going to be easier for pretty much everyone. So I don't know if I'll do like, 1 or 2. If you have a preference, hit me up and let me know. Okay, I will talk to you soon.